Half an hour. It's with a little bit of trepidation that I stand here. Yesterday I opened the file for this paper, which you heard described as Bountiful Science, and the file name read BS Revised. Hopefully this is not my editor's description of what my thoughts were, but just an abbreviation. Anyway, it's a privilege for me to be here and to share with friends and colleagues some of my experiences over the last 50 years. It really has been 50 since I started in geophysics. I can't believe it. But I've had a lot of fun, and that's what it's really all about, isn't it? We contribute, have fun in our endeavors. When I was cut loose in January from EGU, I began to think about how I can use my time and energy now. And one of the good things about coming to this meeting is I got a lot of ideas from people. So this is kind of fun. I'm really devoted to the evolution of our science and our community and the benefits for society. And I'm sure you won't see me disappear. Today I want to just weave a brief story, I think, and if I can finish fast enough, there's an opportunity for a few questions at the end. I want to talk first about what I call boundless science, but and the infinite laboratory and what we work. Second, we have a boundless, essentially worldwide community of Earth and space scientists. And finally, we've got an infrastructure, and that's, as you know, what I've been working in for many years, is the infrastructure, where we've built unions, associations, societies, and at all different levels, and these support our chaotic adventure, if I can put it that way. These three components really are what gives us strength in our community. Rutherford, early in the last century, is reputed to having said that in science there's only physics. Everything else is stamp collecting. I have to confess that I've been pretty nasty about geologists too. Late in the 1960s and into the next decade, I harassed my geology colleagues by claiming that geophysics was the application of science to geology. Those were the days when the geologists themselves were standing up and they would give talks and discount absolutely anything that had been done on a rock in a laboratory. It's in a black box, forget it, it's wrong. Fortunately, I think I've probably grown up a little, and so have those geologists a lot. And we see that in the evolution of our community, is the way we've come together. Earth and space have provided us a boundless laboratory in which we do our work. Neither the oceans or any part of the envelope that surrounds the Earth is respecter of national boundaries or sovereignty. Faults cross anything, rivers, cosmic rays. You know, we're out here in really a place where governments can't define things and shouldn't, and we need to work across them. We're handicapped sometimes by national rules, by political things, by religious constraints, by language, and these are the things we have to get past, and they're one of the things that the societies help us work on. So basically, these barriers limit our effectiveness from time to time, but I think we're learning to reach through them, and we have to do more of that because we're good at it some places and not as good in other places. We sometimes categorize our science in spheres, atmosphere, hydrosphere, cryosphere. Well, you know, these spheres are really interesting, but where the good stuff is, it's when they intersect. And I like to describe it as the grass is always greener under the fence. The natural laboratory we have that you could say it goes out to the heliosphere, it goes beyond the heliosphere now, also has a fourth dimension of time. And we have to worry about time because we're always looking for data, not looking for data out front. We predict that in the models. But when we look backward, we've got to look at things that have gone by and figure out what was there. And so we have to look at data stretching back over generations, over millennia, and even back to the beginning of time. So it's an interesting science we're involved in and a lot of fun. Some of us work on small-scale issues. Some of us are in planetary scale, and you can go beyond that too, and people do. We're all contributing to the same understandings of how the Earth works, how we operate in the solar system, and how that operates in the universe. Often, when one area of our science seems to be drifting off on its own, it suddenly gets this isn't what's written down, but a kick in the butt. For example, earthquake prediction. We see people being concerned about this. I probably shouldn't use the word projection, call it projection, whatever, but this is prediction. We have people claiming to have seen precursors in the ionosphere, and oh boy, are the seismologists mad when something happens and they don't see it. And that's typical, and it's good. It's another part of our field coming in and asking new questions, and that's how we get ahead. And I think these interfaces are really what's important, and it's why we have these kinds of cross-disciplinary societies as EUG and AGU and others, particularly the Asian Society, AGOGs. These are important for that purpose. People are another second thing, and you know, oceanographers, meteorologists, seismologists, you all know we all have names, and we go right through chemistry, physics, mathematics, biology. All those kind of people are in our community because they're working on our topics and they enjoy working with us in our societies. Almost every area of science is applicable to our complex systems and or to how what we learn can be attached to practical things for society. I mean, even down to economics. We need some quantitative economics to look at how we might, for example, alter the climate and what that might do. So we've got to look at those things and include an enormous number of topics in our field as we go along. So our tools are diverse. We've got people in all the disciplines. We've got to keep them happy. We've got to stimulate, and we do that, particularly with meetings like this and with the innovative journals that are being developed, and especially in this new electronic environment where we can slice and dice journals in very interesting times. One of the differences between us and our colleagues in physics was brought home to me the other day. I attended an AGU committee meeting on a Monday, and the next Monday I was in a committee meeting of the American Institute of Physics, and as usual, the AGU members were without ties. They were wandering around, shouting at each other, interrupting each other liberally, and without recognizing the chair. At the AIP meeting, everything was in good order, as you might expect, you know, from a physicist. People were in jackets and ties, sat patiently, and spoke only when the chair recognized them. Well, I commented to one of these physicists sitting next to me. I said, what are the differences here? He said, Fred, you should know. It's really quite easy to understand. When you guys sleep together in the same tent or bunk together on shipboard, you really can't have any pretensions at all. And I should have thought of it myself. Probably right. Done that, been there, and never thought about it. As individual scientists, we can be pretty fractious, and that's really good. It's important. It's what, you know, it's having these arguments that both of us know, or all of us at the table know, is going to advance the science, whether we're right or wrong, because we're going to get something out of it. And that's what this is all about. And we can take pride in what we've discovered, and most of us also admit that we're really having fun. And as I say to my kids all the time, I say, if you're not having fun, do something else. Science, though, requires a kind of integrity and thoroughness that you'll never see in the consciousness of a banker or a businessman or a government official. I think the headlines of newspapers all over the world will tell us that right now. And thank goodness we're actually given the freedom to be honest. We don't have to deliver the things that some of these others have to deliver, but we do have to maintain integrity, and that's probably one of the most important things that we can do through our societies to assure the integrity of science. As a part of the research committee, we have to serve in a lot of capacities to assure that the system goes on. On a gratis basis, we're out there reviewing. You know, you're writing a paper one day, you're reviewing it for someone, another one for someone else. This is all part of assuring the quality of the body of knowledge, and absolutely critical, and it's not going to happen except in a voluntary way. I would guess that you know, there are thousands of people, at least within EGU annually, that are contributing their time and significant amounts of it, and I suspect it's similar numbers in the EUG and also in various societies around the world. I see Jack Hess here, probably in GSA, he'd have the same kind of numbers, big volunteer input. Can't do a meeting without volunteer input. And that's the way we want it to be, because it's our meeting. We're putting it together. We don't get some commercial guy to go out and make us a meeting, because they don't know how to make a scientific meeting, and they won't be flexible enough to change it when we have to change it at the last minute because something interesting has happened, things like that. We have to live with this wonderful community of scientists and work with it at all times and be nimble. I think as a result, maybe I've said it too much, but the typical manager or businessman is not what we deal with. The ethics of science and business are just plain different, and we naturally carry the ethics of work through life. It's the way we start, and if we're well trained, it's the way we bring our students up, and we continue it. And if we lose it, we lose credibility. And credibility is very important for science, absolutely critical. And you can lose it in a day, and it won't come back. We in the Earth and space science have grown over the last several decades into an important global community, and we have room to grow more. It's natural for people to explore common interests, and that's what the associations can do to help us. They can help us focus. Societies, disciplinary societies, broad societies can help us focus. Go to the first polar year 125 years ago, and that was really a harbinger of the international things that we pulled together with the IGY later, in the International Physical Year. IUGG was formed in 1919 after the First World War, but again, things started to build, and actually AGU came into being as part of the IUGG buildup. It was the U.S. National Committee for IUGG from 1919 until about 2000. And AGU was actually part of the Academy of Sciences in the U.S. until 1972. Well, that's just an aside. I think, and I want to mention this, one of the signal evidences of the evolution of our science was the merger between EUG and EGS. I think EGU, anyhow. That merger showed that we could bring this community together in ways that we hadn't done it before, and it was fabulous. But let me go back to Keith Runcorn and the meeting in Reading. I was there too. But my predecessor, Waldo Smith, was actually at the one of the earlier meetings, and he was the groundbreaker from the U.S. He came over and worked with Chris Argent and the Royal Society group that had worked with Keith. And so I went through a 3-year overlap with Waldo, and boy, was I glad when I took over the AGU at age 32. If I hadn't had those 3 years, I don't know. It was great and fun, too. But anyhow, in 71, my first year on the job, the AGU president was Homer Newell. Some of you may remember him, space scientist. And Keith invited us both to come over to this Reading meeting and to please bring the AGU statutes with us and bylaws. Well, it turns out that in those first statutes and bylaws, there were a lot of similarities with the AGU ones. And imitation is the sincerest form of flattery. And we worked over the years very closely with EGS, as you know. Actually, taking the bylaws to Keith wasn't the last favor that he asked of us. Over the years, he'd show up at the AGU booth and the EGS meeting regularly, and he'd want something. His membership hadn't been paid, or he needed a book. But the topper was the second meeting in Grenoble, I think, and Keith showed up and asked if he could plug into our power supply. Next thing we know, he's standing there shaving. Keith was a great guy. Anyway, apparently the razor he had wouldn't work in his lodgings, or maybe French electricity rejected him. EGS was more flexible from the beginning than AGU in many ways than its counterpart. It was already 50 years old across the river there, the Atlantic. Until 72, AGU didn't even allow non-US people to be members. And that was because of the formality of the US National Committee. Over that first 10 years, while EGS was establishing itself, AGU and EGS worked closely. We published the abstracts at AGU for the EGS meetings for a number of years until EGS got its publication program going. And after that, there were, well, I participated in council meeting after council meeting for the first 10 years or so until shortly after Arnie came in. And Arnie and I have been close friends since that time. We've had a very good relationship over the years. I think we've exchanged booths. And in the early 80s, when the Secretariat was established in EGS and you decided to develop Copernicus, one of the things, by sharing the cost of Copernicus, it would enable EGS to put together a viable group in Lindau. And it also helped AGU because we got services in Europe that we would not have otherwise had. So between the two, we helped again to work together. And this partnership over the years has been essentially with no strings attached. We have made it work comfortably and largely in an informal way. And I would argue that that's an important thing to do in bringing societies together. If you can do things informally, people get happy about them, they work with them hard, and you don't have to tie people down in long contracts and things like that. You just get things done. I have a note here that says, strong national and regional scientific organizations strengthen the whole community of Earth and space scientists. And you better believe it, they do. The more people we can get into the networks, the more people we can communicate around the world, the stronger this community of scientists is going to be. We have to keep working on that. We in Europe also have to, and the United States and the wealthier parts of Asia need to realize that most of the data comes from the rest of the world, doesn't come from us. We don't all know the land. And working with other countries, and the unions are particularly useful with this. I think the IUGS and the IUGG in reaching out to the developing countries, and some of us, at least AGU, we may not have been as good at being able to reach into the unions and capitalize on that. And I think we have some new opportunities there. We've got some new leadership and some new ideas with the unions, and I think that we'll see this blossom in the next 10, 15 years. There are some pitfalls as we go about things, and we want to go strengthening our favorite society and its links, and that's an important thing to do. But there's some things you should worry about. One of them is how you handle advocacy. We all want to make our science more useful, and one of the ways you make it more useful is it gets used in making sound policy. But we have to be very careful that we don't overstep the line and try to argue for something that is of political interest but goes beyond the science that we've already developed. Because once you do that, you begin to lose a glint of credibility because you're asking for something beyond what you know as a scientist. And you ought to be asking that as an individual, not as a scientist. And particularly not as a scientist representing a society that's put this together. EGU has gotten that exactly right as far as I read everything, and is really doing a nice job there. And I think that the more societies around the world can work together in developing these scientific statements that can be used by national societies, the better off we're going to be, because those national societies are where you can sell things. They're the ones that have the credibility in their governments and in the companies in their countries. So if we can work with them and help them gain credibility too, I think we would move to a much stronger position. We would move to a stronger position in terms of support for ourselves, but also in terms of actually getting what we learn used where it needs to be used most. I've done the usual thing. I haven't followed my text, so I'll just skip things. I think that one of the things you ought to look at very hard when you're managing a society is if a society is established for the public good, you really need to assure that the affairs of that society are operated by and for the membership. And that requires a complete openness. Members have to know what's going on or they feel left out. And that's often we make that mistake, and it shouldn't be made. The leaders, in my opinion, talk about a characteristic of scientific societies is really the boundless enthusiasm that all the members have for their work, and that same passion needs to be in the leaders, in the presidents, in the council members, and in the staff. I mean, I loved it when I could walk into the staff office and realize that they're in tune with what we're trying to do. And people came to work for AGU, and they probably do for EGS because they like what we do. And that's really important. You've got a team that really wants to do a job. I've already talked about integrity, and I've probably said enough on that subject, and I've drifted a little bit, but that's all right. I think another thing we ought to look at is values. AGU adopted a set of values a few years ago, and it printed them up. Well, values aren't to be printed. Values are to be lived every day. And I think it would do us some good as an entire community to look solidly at some of the values that we have and make sure that our members know what those values are, and they're few enough and clear enough that we live them every day. And I would argue that it might be worth just take a look at the EGU website sometime, and there are probably 7 or 8 of them there, 4 of which are really important, and the others are important too, but in different ways. And I think that working with the unions might be a good idea, a good way to develop some of these values for us, because they're a little different from the EGU things that do exist. Okay, anyway, I'm going to finish, because I can give you 4 minutes of questions then. We've built on the shoulders of a lot of giants, and we've had a lot of fun doing it, but it's an unending process, and we've got to keep building giants and keep standing on their shoulders, and we're going ahead. Less than 100 years ago, we were pretty much limited to the surface of this planet. Today, we're getting data from the other side of the heliopause, and there's more out there. We're lucky that we have diverse societies in our community so that we can maintain a focus on a variety of problems. But these societies do need to get together in the bigger picture. And we got to think about global data, because global data comes from around the globe, and you can't get at it in some places because of these artificial barriers. And we want to get past those, and working with other societies will help us do it. Our ground is fertile for collaboration. Collaboration brings benefits, and as long as you focus on objectives and pick the right partners, you can get ahead. And one to remember, the good that you can do is boundless if you don't mind who gets the credit. Thanks. And thank you for this award. Anybody have any questions?
Well, I think that's an excellent motto to live up to. Are there any questions to Fred? Yes, Dan.
Maybe more than ever before, science is being looked to as the possible salvation for society, and to restore flagging economies. And in the United States, at least, it's lots of funding is being quickly devoted to science. Do you believe that science is going to be able to nimbly, quickly respond and step up to the task?
No. And I think if we fake it, we'll be in real trouble. I think that we're going to be doing things, certainly, but science isn't going to move fastly and nimbly. It's going to move logically, and if we overstep, we're making a big mistake if we offer too much and can't get through it. Integrity. Yeah, the interface of the non-scientist and the scientist and where it is an interesting question. Certainly, it's if people are interested, it's good to include them one way or another. Beyond that, it may be that we're trying to do outreach. But it's nice to have some of that community inreaching, and certainly I think including people in opportunities to hear lectures and things like that, or even to get journals and read them themselves if they want to, is a good thing to do. It helps make the impedance match with the whole public.
Further questions? Yes.
Yeah, Fred, we've seen this meeting grow enormously since the society joined. We've seen EGU San Francisco meeting grow by 10% a year over the last several years. Do you see a maximum effective size for a meeting like this, or do you see us growing 10% a year for the next decade?
That's a good question. 10% a year, we're worrying about San Francisco big enough. And I'm sure there's worry here about, is this place big enough and where are we going to go if we have to change? But those are mechanical things, and I think we have to learn how we're going to handle that. In other words, we've got to meet what the community thinks is the best thing to do. And obviously, if the community wants to have these large meetings, and people come and complain, and what I have been saying for a long time is when you stop coming, then I'll figure out another thing, what you really want to do. But tell me what you want to do. We want smaller meetings. Yeah, but you want smaller meetings, but you want everything that's here, don't you? Yeah. So I think we have to go with the community, and maybe we want to try some different alternatives to slow things down. We did this years ago. Probably nobody here would remember this, a few. The meeting in Washington, the EGU had a meeting in Washington. It got so big that we thought we had to take pressure off that meeting. It was 2,500 people. So we started this little meeting in San Francisco. 10 years later, we were wondering how we were going to take pressure off the San Francisco meeting, and we've been worrying ever since. And should everybody have worries like that? It's an enormous meeting. It's an extraordinarily successful meeting. This one is too. Watch it, worry about it, but don't screw it up.